Good morning, everyone. My name is Billy Odera. I work at Commercial Bank of Africa. So I build credit models. So if you don't have an M-Shwari or Fuliza limit, you can see me, sidebar. But anyway, on a light note. So it's a pleasure to be here. It's nice to see you guys. I know a few guys here, but you are welcomed. So today we want to talk about a classical machine learning problem, which is a loan prediction challenge. So these are my contacts. So you can email me, LinkedIn, Twitter, GitHub. I live dangerously. I push to GitHub minutes before my presentation. But so for this course, I haven't pushed the notebook to GitHub because I'd like us to go through the notebook together. So after this, I'll push the notebook to GitHub. So if you have time, you can go and check it out. So those are my contacts. So just to start, there's this quote that I really find it interesting. Aim for simplicity in data science. Real creativity won't make things more complex. Instead, it will simplify them. And throughout the challenge, this quote will manifest itself. So it's very important for you as a data scientist to always make things simple. You don't need to do a lot of complex stuff. And we'll look into that as we go along. So the agenda for the day is we'll start with an introduction to machine learning, then we'll do credit risk models, then we'll do the challenge. So feel free to interject if you have a question or if you have anything you want to say, just feel free to interject so that it can be we can both communicate and understand each other. So what is machine learning? So this is just for your own good. I won't talk about it. You can go and Google it. But basically, we have three types of machine learning problems. And machine learning right now is being used in like every sector that we are in. If you talk about Uber, you talk about banking sector where I work, Netflix, medical, diagnostics. So it's our day-to-day life, and we try to use machine learning to make life easier for us. Back in the days, if you were to apply for a loan, you'll have to bring your electricity bill, you bring your location, you bring a recommendation letter from your chief. But right now, if you are an M-Pesa user, you can just go to M-Shwari, you're able to access credit, or you can overdraw your M-Pesa wallet through Fuliza. So life is becoming easy because of machine learning. And there are three types of machine learning which I want us to focus today. We have what we call the supervised learning, and basically supervised learning is where you are given labels, so you try to train the machine to predict the labels that you have. And a classical example is things like classifications, regression, and decision trees. So we have also unsupervised learning, and unsupervised learning is you don't have the labels, so you just try to train the machine to identify patterns in between your data. Things like clustering, segmentations fall under that. And then we have reinforcement learning, where the machine is adapting to the environmental features. So for instance, if you have a program like a game of chess, so any move that you make, the machine is able to adjust its move based on the inputs that you give it. So this is so supervised learning. We have basically two branches. We have regression and we have classification. So regression is where the target label or what you're trying to predict is continuous. And then for classification is it's discrete, so it can either be binary, like what we'll tackle today, or you can have multi-class. And then for unsupervised learning, use clustering and compression. So basically, you have data and you're trying to train the machine to identify patterns within your data. And then reinforcement learning, as I said, the machine adapts to the environment. So I want to talk about credit risk modeling. And for me, I think the approach that you take when doing machine learning is important. It's good to learn code, but you can easily teach someone how to code. But it's very hard for you to teach someone how to think. So critical thinking is very key in any approach that you try to do. So coding is a skill that you can easily learn, but how you think through the problem that you have is something that can take time, and that's the area that I usually would prefer most of us to focus on. Instead of just getting a problem and you're jumping writing code, it's just step back, understand the problem, and just try to think through the problem before even you apply the machine learning techniques that you've learned. So, so for data mining processes, there's one recommended approach that the industry sort of when you're doing machine learning, and it's called the CRISP-DM. It's cross-industry standard process for data mining. For software development, guys, I know there are a couple of software engineers here. You sort of do the agile framework. You deliver them in sort of sprints. But for machine learning, it then becomes difficult if you don't have a well-structured plan. How do you then go through it? Because you'll be having problems where you have a lot of data coming in, and there's also high expectations from the business. So this is one of the platforms that is recommended when doing data mining projects. And you basically start from business understanding. And so any problem that you try to solve, it's really important for you to it's important for you to apply your machine learning skills to solve a problem. You are not going to do machine learning because it's fun. Okay, I know it's fun. It's the buzzword right now. Everyone wants to do machine learning. Everyone is a data scientist. But in the real world, you want to solve problems from business. And so the first step really is to understand the problem. What is it that you are trying to help the business to achieve? And this is the most important phase, even before you apply your algorithms, because you need to understand what are the objectives, what is the current situation. For instance, someone will come to you and tell you, we want to know our customers better. So you as a data scientist and the data that the company has, how then do you make use of that data? So you really need to understand, okay, do you want to segment the customers? If you want to segment, then how do you want to segment? What is the problem? Because if you then don't understand the objectives, even the model that you will have downstream, you are not able then to justify the model that you have. So it's very important for you to, in the first stages, just set out the objectives. What is it that you want to achieve? So that at the end of the day, once you have your model, then your model can answer those questions that you set them out. And then the second step is data understanding. And This is where now you try to get data. If you're running, you have a data warehouse, so you try to figure which data is where. So you try to group your data sources. Maybe you have social media data, you have transactional data, you have all sorts of data. So at this stage is where you identify your data sources, and then you go to data preparation. And a lot of guys are saying this is a step where they take almost 70% of their time. So you're just trying to clean your data, you're trying to make sense of the data. Is the data actually making sense? You try to do validations on the data. For instance, if I'm going to build a model and I get data about customers, say for instance, something like M-Pesa transactions. If you are to be given, say, data about your M-Pesa usage, the first thing we know is we have a cap of the amount that you can send within a day. So when you get the data, you just try to look at what's the maximum amount. If you're looking at data for a day, then you see there's a value there, an observation that has an M-Pesa, say, probably receive amount of 200,000. Does it really make sense? So this is what you are going to do on a day-to-day basis. So you are just trying to understand the data. Does the data make sense? If not, then you clean the data. So after cleaning the data, this is now where you go to your modeling stage. So this is the fun bit. Unfortunately, it's only 5%. Like personally, I spend 5% of my time here because algorithms are there. If it's your regression, we have libraries which you can just then push in your data and you're able to get results for the same. And then, of course, after that, you have to evaluate your model. I think this is one of the areas that is becoming more critical. So you've built your model for guys like me who work in the banking industry. So once you have your model, then the model has to be approved before it's applied in production. So you have your model, then your boss comes and tells you, so explain to me how does this model make its decisions. So, and you have to explain not in statistical terms, but in a language that the guys can understand, because you have to explain in English. So, and because if the guys don't understand, then you won't get the approval. So all the work you've done, you'll just have built a good model, but it will be for you. Yeah. So this is one of the areas I feel like we really need to get into. Good thing is we have libraries now that are trying to make it easier for us. Libraries like Eli5. Who has used Eli5 here? So guys, just check it out. Eli5, it's ELI then 5. So basically it means explain like I'm 5. So, and then we have libraries like Lime and Sharp. So they are just trying to make model interpretation a bit easier. So your black box models or white box models for you to be able to understand. So after evaluation and you have your performance metrics and we look into this, maybe you've built your dummy classifier, so you have a metric and you feel like right now my model has a better accuracy, if that's the measure that you want to go with. Then you deploy your model, and deployment depends in the kind of infrastructure that you are running. So whether if you want to deploy it as a web app or any other approach that you want to do. So that's what you'll do at that stage. So I want us to jump into the challenge because I think this is where maybe guys will have a lot of questions. Another quote that I like, models are opinions embedded in mathematics. So, and there's a quote, there's a business guy who was telling me that if you are going for a presentation and anything that you are saying is based on opinions and not data. So he was telling me if it's opinions, then we'll go with my opinion. But if it's data, I'll go with what the data is saying. So let's jump out, just for me to understand, how many guys have used Anaconda and Jupyter? Just by a show of hands. So how many guys haven't used it? So that I just know, okay, I know the pace that I'll be going. Okay, sawa sawa. Don't worry, I hope by the end of this you'll be able to do it. So I know, I think you all know where the challenge is. It's Zindi Africa, the Data Science Nigeria Loan Prediction Challenge. So you'll get your data sets from there. And I hope each one and every one of us, we have the data set, yeah? So Zindi is a platform where guys go to compete. I'm sure you guys have heard of Kaggle. So Zindi is like Kaggle, but I think it's for Africa. So there's this challenge, loan default prediction, and there's that company, SuperLender, does credit risk modeling. So they're going to have two main risk drivers. So you have willingness to pay and ability to pay. And then they basically want you to your job is to predict if the loan is good or bad, and accurately predict the binary outcome variable where good is 1 and bad is 0. And then they've given you, I think the data sets are 6. You have a trained data set and a test data set. So the first thing that you need to do is, as we had talked about the crisp DM process, is for you to be able to understand what is the challenge. That's the first step that you need to do. So we've been given data, and what we need to do is we are to predict the outcome for good and bad, and I think the measure is the best score is based on, I think, error misclassification rate. I think that's the measure they are using. So this is a classical machine learning problem. So just looking at the data, I can know that this is a supervised problem because I've been given data, and then I've been given labels that I'm going to train the machine on. And that label is the good, bad column. So you have data, your predictors, and then you have the outcome. So what you are going to do is for you to train the machine based on the features that you have, for the machine to be able to predict that outcome. And then now you have your test data set, which you are going to run through the model that you've built, and then you're able to see the results that you are getting. So that's a supervised problem that we are talking about. And it's a binary classification problem because the labels are either good or bad, or 0 or 1. So it can be good, bad, 0, 1, true, false, like that, and it's binary, so it's only 2. So the other cases where the label is it's more than 2, so you can have 1, 2, 3. You can have like strong, medium, weak. So it depends with the problem that you are given. We've been given the description of the data. So this comes with the challenge. But in real life scenarios, you are the one who is going to define these. If you are in the field, no one will define for you these parameters. It's for you to create your data dictionary, and then first you create your data requirements, then you create your data dictionary, then now you apply the data. And that's why you see a lot of guys who are saying that they actually spend 70% of their time doing this work. But for these competitions, you are lucky The data has already been prepared. You have the dictionary. So for you, it's just to apply your thinking and your ML models to the data. So we have demographics data, and so these are basically, like, I think, static data about the customer. So your customer number, yes. Anyway, as I said, I'll put the notebooks in GitHub. The reason why I don't want to put it now is if I give you guys now, I know guys will run the whole notebook and go to the results. So, so yeah. So after this, you'll have the code. So don't worry. But before you get the code, at least we need to interact, so that when I give you the code, then what I'm saying actually makes sense. I'm using Jupyter Lab. How many guys have used Jupyter Lab? Yeah, so I moved from notebook. I find it better, but I'm also now moving out of notebooks. I'm going to VS Code, but so I think they're trying to do a good job in making the IDE integrate with machine learning. You can actually run your notebooks from VS Code, and you can even import your Jupyter notebooks into VS Code. So I think it just gives reproducibility. It's better using VS Code, but for purposes of learning, I think Jupyter is the best. You have a question? Oh, okay. So we already know what the problem is. So our job is to predict good and bad, and so as I was explaining through the data, we have demographics data. So these are sort of static data about the customer. Things like your age, your customer number, the bank account type, is it a primary account, savings account, longitude and latitude. I think this is for your location where you stay. And then your name, the name of your bank, your employment status, are you permanent, contract, then your education level. And then we have performance data. So this is how the current loan is performing. So you have your loan ID, customer ID, the loan number, when the loan was created, when the loan was approved, the loan amount, the total due, which is your repayment minus, I think, interest plus the principal plus interest minus repayment. Then you have the term of the loan. Is it a 30-day, 60-day product? And then referred. If it's missing, then there's no one who referred you. And then you have the good, bad, which is what we are going to predict. Yeah. And then we have your previous loans data. So this is if you ever took a loan before, so how was the loan performing? So that's just basically an explanation of the entire problem. So now having the data, we can then proceed. So now that there are guys who've never used Jupyter before, so there are libraries that will help us to do these machine learning problems a bit easier. And one of the libraries is one of the softwares is Anaconda. And the beauty about Anaconda is that it comes installed with certain libraries that we need. It will come with your Spider IDE. It will come with your Jupyter Notebook. I think you can also install our Studio and things like that. So once you have Anaconda installed in your machine, you then need to install the libraries. So the first thing I'm doing is I'm importing my libraries, and if you don't have these libraries, you can actually install them. You can either install them through pip or Conda. So you can either do conda install pandas or pip install pandas like that. So the first library that, so there are basically about like 3 libraries which are critical for your data exploration and visualization. Have pandas, which allows you to manipulate tabular data. You have NumPy for numerical computing, and then you have matplotlib. So matplot is for visualizations. So those 3 libraries, anytime I'm doing any project, be it data exploration or machine, these are libraries that I know I must have. So then I'm importing it as an alias, and that's why I don't want to be typing pandas every time. So that's why I'm importing pandas as PD. So anytime I want to use a method in pandas, I'll just do pd dot something, yeah. So and these are standard aliases. So you can use any alias that you want, but you'll confuse people. So if you are the kind of developer who writes unmaintainable code, so that when you leave, no one can actually know what you are doing, then you can interchange these things and you import pandas using your name or something like that. But it's not recommended. So these are the industry standards. So anytime, even if I give you my code and you see pd dot something, you can just know this is pandas class or method like that. So I have Seaborn. So Seaborn is just an extension of matplot. It just gives you different visualization. I have date.time, and then for statistical analysis, I'm using SciPy. I'm importing stats. Then I have IPython display, and then I want to suppress my warnings. So anytime I get a warning, of deprecated methods or things like that, I don't want to see them. Then file system management and memory management. So especially if you are dealing with big data sets, it's very important for you to manage your memory as you're working along. So you don't want to be running code and then you run code for the whole day. So then these are my personal preferences. I just like to have them set. So one is I want to make the maximum number of columns that I'm working with to be at least 200 so that I can see them or scroll. Because there are times you will be working with data sets that have, say, like 1,000 columns or stuff like that. Then I want the rows to be limited to, I actually use 10, but there's something that I was doing downstream that I then had to override it with 30, so that it just makes my outputs visible when I'm doing them. For this bit, this is just my personal preference. So it's not part of what you should be doing. It's just a few things that I've worked with, and then I find it to be useful. So for this code, what I'm doing, I'm suppressing scientific notations. So I don't want to see numbers like, say, 0.1, then there's like a E there, 3, 4, 5. So I just want to see the whole number. And how many guys have used R? So R, guys, ggplot. So I just like the aesthetics of ggplot. So I want my visuals to be the same as ggplot. And then I'm specifying the figures that I'm going to plot. So this is PLT. Remember, I imported matplotlib.pyplot as PLT. So I just want the matplot figures to be at least 18 by 8, so that I don't have too small figures or big figures that I need to scroll. Then I want my outputs to be SVG format, and then I'm importing matplotlib inline so that I can be able to see the output of my code just below the cell. Yes. So I've imported warnings. Then in warnings, filter, I want to ignore my warnings. Yeah, so I don't, if there's any warning, I don't want to see it. So that's basically what I'm doing. So the first thing I'm doing is I want to load my data. And the data, so when I got the data, what I did, I actually opened the data in Excel. So I just had a look at the data. So I know the data is in tabular form, where I have columns and rows. So this is what, and then I know the columns that have date columns. So this is basically what I'm doing. I'm importing now the CSV into my notebook, and I'll use pandas. So pandas, read CSV, and then all the 6 data sets. And then if a column is a date, I want to pass it as a date, so that when I get the outputs, they are all formatted. Date formats have already been formatted. Else I'll have to again convert them after I've imported. So that's basically what I'm doing. So if you have your data stored in a folder like my documents, you'll have to go to my documents. They're in the same folder. So you have your notebook and your data. Inside my folder called notebooks is where I have my Jupyter notebook. And so for guys who have Unix guys, so for me to go back, that's why I'm doing two dots. Then I specify the path. So I go back to the parent directory, which is now my DNS challenge. Then I go to the path. So for your case, if your data and your notebook are in the same folder, you don't need to specify this path. So you'll just write the data name. So the name of the CSV. So if it's test demographics, you just put test demographics.csv. Yeah. So there are other better ways to do it. There are better ways where you can write a function that just reads the names of your data sets, and then you don't need to type. But I think for a start, this is good enough. Once you've loaded your data, the next thing is I just want to know the shape of my data. So basically, I want to know the number of columns that I'm going to deal with and the number of rows. So we have this dot shape, which I'm using to get the number of rows and columns. So like for the test demographic data set, we have 4,368 observations, and then we have 10 columns. So I'm doing it for all the data that I've uploaded. So, and then what I want to do is I just want to make sure that the data that I've imported is actually fine. So, and this is the IPython display that I was using. Then I use .head. So basically to see the first few rows of the data set. So the reason why I was using display is because I want to see all the data sets one after the other. So I'll have had to do like a print or something like that. So for this first one, so this is a test demographic. You can see the customer ID, the birth date, account, and all the details. So now that I have my data ready, there are certain libraries that you will definitely need to install. Like if you check the notebook, the first library, the watermark library, that one you need to install. So once I've imported my data, I've looked at the structure of the data, I know the number of rows, I know the number of columns. I've verified that actually the data that I've imported is okay. I can see that the date columns are well formatted as dates. Now I start exploration. So for this particular challenge, one thing I noticed is how you merge your data sets is actually very important. If if you merge your data sets wrongly, you end up overfitting in your model. So that's what I learned when I was doing this challenge. So you have to be very, very careful on how are you going to merge your data sets. Because you have 3 sets of trained data sets, and then you have 3 sets of test data sets. In real life scenario, you'll just have like 1 data set. Then what you do is when you're building your model, you partition your data sets either into 2 or 3. You have a train, say 70% train, 30% test, or you can partition it into 3 where you have 50% train, 25% test, and then 25% validation, just to make sure that your model is not overfitting. Then you pick an out of sample data for you to validate your model. So maybe if you are looking at say loans that customers who took loans in 2015, you've built your model on that data, so you now probably take loans of 2016 and try to run it in the model and see if you'll get same results. So for this case, we have 3 data sets, and how you are going to join the data sets is it's very critical. So the way that we have to look at it is we have like 3 types of joins. So you can either do a left join, a right join, or an inner join. So for a left join, you have your records on the left, so you want to get everything, all the records on the left will remain, so you just add data from the right side. For a right join, it's the opposite, and then for an inner join, you just want to get the records that match. And in Python, and I just want to mention this so that at least when you guys are going to do the challenge, because I'll want you guys to beat my score and maybe share with me what you did differently. In Python, there are 3 ways in which you can join your data set. So you have, you can either merge, you can either concat, or concatenation and a join. So a merge is like you'll be combining your data sets based on indices. So maybe you want to combine your data set on customer ID. So like for instance, we know that my train performance data has customer ID, and then my train demographics data has customer ID. So I'll merge the 2 data sets based on that index. For concatenation is basically you are appending records to the other table. So you have your train, say your train data set, then you have say train demographic and then train performance. So you're basically appending the performance data on the train data set. And basically a join is just a merge for the 2 data sets. So that's I think one of the few things I learned when I was doing this challenge. So there's a way I was merging, and my model was overfitting. So I'll get performance of about 0.8 accuracy on the training set, but when I try to validate on the validation set, I get about 0.6, 0.5 there. So that's what you need to do. So yes.
So imagine.
Yeah. So and I'll just show you why I brought the concept of merging. So remember, when you are preparing your data set, you'll probably do feature engineering. So you'll probably want to create new features. And if you've created new features, you then need to make sure that the features you've created are actually in the test data set. So that if you've created a feature like, say, average loan balance, which is not in the data set that you've been provided with. So it's a new feature you've created. So you need to make sure that feature is on your train set and on your test set. So if you don't merge your data sets, you repeat the same process across all the 6 data sets. So it's going to be time consuming and boring, by the way. If you are going to do the same exercise every time you copy and paste and you repeat across the data sets, then it's going to be very boring. And I'll just show you the why merging is important in this data set. And then the thing that you need to note when you are merging is if you have duplicates in your records, what Python does, it will give you a combination of every data set. So if you have any missing value or a duplicate, it will still try to merge that data set. So you have like say you have 2,000 rows, and then you are merging with a data set that has say 3,000 rows. Then all of a sudden you see like you have 15,000 records. So you also need to remove duplicates before you merge. If you merge with duplicates, you are going to, because what it does, it creates a combination of your rows and your columns based on, if it finds a matching value, it will try to create a combination for that for the entire row. So you need to be very careful with that. So once you have your data, so you need to explore your data. And for me, this is the most critical stage in any problem that I want to do. The first thing I want, the thing that I want to be sure of is that I know my data, I understand my data, so that even if you come and challenge my results, then I can be able to explain to you what exactly I did. So data exploration is a very key stage. There's usually a question of if you have a data that has, say, 300 columns, do you still go through all the 300 columns? Or if you have a data that has 500 columns, will you explore every column one by one? Thoughts on that? Will you or will you not? No. Will you or will you not?
Thinking.
Yeah.
They're correlated.
No, you don't know if they're correlated. So you've just been given data.
First, just check correlation of the columns.
So you'll want to reduce based on correlation. And if the variable that you've dropped is actually the variable that is critical, I will do correlation after I've explored my data. So that if I have two variables that are related, say I have a variable income 6 months and income 3 months, they are correlated. I'll then have to decide, do I drop the 6 months or 3 months based on certain metrics that I want to define. So will you or will you not? I've not. There's one guy who said no. Anyone for a yes? I'm the only one who will stand for yes. Eh? So if it's 300, say 200 and below, I'll look at all the variables. Even if it means I spend my data exploration for a week, I look at all the variables. Because remember, for guys like us who are in the banking industry, if your model is wrong, you're talking about losses in millions. So would you risk losing millions because you just spend extra time on looking at the data? So it's a question of you want to build intelligent models, not just models. So I think, and this is the phase where I feel like, okay, in these competitions, it doesn't matter. You can decide not to even explore the data. You just run your model. But in real life scenario, you really need to look at every feature at an individual level, so that you are able to understand if there's any skewness in the data. Because remember, you are a data scientist. You are not a credit guy. So if you are, say if you are building a model about, like the one I saw, the Busara challenge, you are not a doctor. So you don't know if my depression level is 0.6, you don't know what it means. You don't know, say for instance, if your data is telling you men are more depressed than ladies. You are a data scientist, you can't explain it. You are not the domain expert. So the reason why you do exploration is for you then to go to the domain expert and try to validate what the data is telling you is actually what is happening in real life. If, for instance, I'm looking at a transactional data and I realize that even, say, age, if you are looking at something like age, you would expect age to have a normal distribution where you have few guys at the lower band, few guys who are very old, and then the bulk of the guys are between, say, age 15 to 45. So if you suddenly find that age is not distributed normally, then you then start questioning what is happening. And or say, for instance, you are building a credit model and you're using age. And then you see a few guys who have 4, 5 years, 6 years, and you know to open a bank account you need to be 18 years. So these are the things that you need to question. So you don't just, you should always have that instinct of questioning your data. You should not always trust your data. So for me, I'll go through all my variables. At least if they're about 200 and below, I look at it variable by variable. There are guys who prefer to maybe do correlation, as I was saying. For guys who build credit models, then you will probably look at things like information value and weight of evidence and try to rank your variables and be able just to pick the variables that are useful. But for me, what I would advise you guys, don't be lazy. Just look at the data. Even if you spend a week on it. So what I'm doing here, I'm just looking at the columns, just to make sure that I have the columns. And so we have numerical and categorical variables. So you have numerical, basically, you look at things, continuous variables. So in Python, they can either be a float or an int. So these are things like your salary, loan amount, and then we have categorical variables. So say, for instance, gender, you're either male or female. Your banking bank type, so it's either a savings account, a current account, and stuff like that. So what I'm doing is I basically want to know the distribution of the variables in my entire data set. So for the test demographics data, I can see that I have 6 categorical variables, 2 float variables, and 1 date time. So at this stage, I just want to have a feel of the data. I'm not even working on the data, just to have a feel so that I know the type of data that I'm going to work with. So there's a library that makes it easy for us. It's called Pandas Profiling. So what it does, it gives you a summary of your variables. So at times when I'm a bit lazy, I use it. So you import Pandas Profiling, then you run Pandas Profiling in your data. So you can either have it as I think an image or an HTML document. So let me just open the output. So I had commented it because it's time consuming, and I was rerunning my notebook every time. So for the first time, you just uncomment those cells, so that you are able to also get the report from your side. I'll use the report for test I think let's just for illustration use test demographic. So this is the output that you'll get from pandas profiling. So it will tell you the number of variables. There are 9. The observations are that. Missing percentage in your data set, it will give you. It has also specified to you the variable distribution, which I was getting with the data types. Remember what I was telling you, my numerical, categorical, I just want to have a feel of it. Then it will give you the warnings. For instance, bank branch clients, it has about 99.1% missing. So customer ID has high cardinality. We expect it because every customer has a unique identifier. So, and then down here, it just gives you the distribution of the variables. So it's a very good library just for you to have a feel of the data. So you can always use it, and I like it a lot. So that's what I was doing there, and I was doing it for all my data sets. So I did it for all the data sets. So now I now have a feel of the data. I know the variables that have high cardinality. I know the variables that are categorical. I know my numeric variables. I know how the shape of the data. I know I have like 1,400 records. I have like 9 columns. So I know all that. So the next step is for me now to prepare my data. So at this stage, I already have a feel. I know how the data looks like. What I wanted to do to avoid, because I'm going to do merges, to avoid data leakage, I then created a new column called set. So in this column, I'll specify whether my data is from the train group or the test group. So like train demographics, I just set and I put it to train, so that when I merge the data sets, I have a column that after doing all the data preparation and feature engineering, I can then separate the data sets. So I needed a column that will enable me to separate the data sets. So this is what I'm doing here. I'm creating a new column, because when I want to do feature engineering and when I want to do data exploration, I don't want to repeat the steps for the 6 data sets. So if I have a train demographics and a test demographic, they have the same columns. It's just that this is for training and this is for testing. So if I'm going to calculate, say, age, because we've been given date of birth, I don't want to calculate age in the train demographic, and then I repeat the same process in the test demographic. So I'd rather merge them, then I do it once. So that's why I now had this column, so that after I've completed all my processes, I can then use this column called set to separate them. So I did a concat, and as I said, concatenation is basically your appending. So if you have your train demographics, and then I'm just adding the test demographics. I have 3 data sets that are train. I have 3 data sets that are tests. So I'm not splitting. I just want to join them, so that if I'm working on demographics data, I work on both the train demographic and test demographic. So for splitting will come down now when after I've prepared my data set, I want to model, that's when I'll split. So for this one, it's just to enable me, after all this process of cleaning, preparation, I can then separate and have my 6 unique data sets the way I had. So it's to avoid, as I said initially when I was doing this challenge, I realized that I was overfitting. So there was sort of data leakage in my whole merging process. So I said the pandas profiling library is enabled to give you, will give you a summary of your data set, from missing values to the variable types. So what I did, you can either have the output as an HTML or an image, whatever you decide. So you see what I did, I imported the library. I've commented this because when I run the notebook, I don't want to do the same process again. So profile, I call the pandas profiling, then I want a profile report for that data set. This is the first line. So I want a profile report for this data set. But then I want this this profile in a place that I can open it even for future use. I want to see it. So what I'm doing for this variable that I've created called profile, then I specify that I want it as a HTML document, and that this is just a path in my machine. So in my project, I usually have a I have a folder for data science challenge. Inside the folder, I have a folder for data, notebooks, reports, documentation, just to enable me to have things organized there. So all my reports are going in a folder called reports. So under reports, I'll have images, I'll have HTMLs. So now this one is going into an HTML folder. Okay? So now I have 3 data sets, because I've realized the train and test data sets are the same for a specific category. So if it's demographics, they all have the same columns. So what I'm doing is I'm just appending. So that's why I'm using the concat. Eh? So and then I call it T demographics, T performance, and T previous. Eh? Then I want to create my response variable. Eh? So we've been given the column good, bad, this one. So I want to change it into numerical, so that I can be able to work on it. So if good, I'm giving it a 1, and bad is 0. I think I've interchanged. Eh? I think the challenge was saying good was 0. Or good was 1. Yeah, okay. Bad was 0, yeah. So that's what I'm doing. So I'm changing from good, bad into numerical, so that even when I'm going to do my exploration, I then have 1s and 0s. Eh? And then I've mapped it now. So instead of good, bad, it's now 1 and 0. So after mapping my good, bad, I then want to see how is the distribution of my response variable, because this is what we are trying to predict. So I want to know how is it distributed. So and this is the code to do it. So basically, look at the train set. I'm basically doing a value count, eh? And then I plotted a pie chart. So this is how it looks. So I have 22% guys who are bad. So I've labeled them as defaulters. And then 78% of the guys are good. And then this is actually the opposite. Eh? No, good is 1, yeah. So good, bad. The number, and then the distribution. So that's basically what I did. So pandas profiling would have given me the distribution of missing. Eh? But you see, the report is so long, so at times I don't like using that report. So what I did is I then decided to calculate the percentage of missing when I'm coding along my notebook. So basically, it's just you are looking at null is a function that sums up all your null values, and then you're dividing it with the length of the data frame, which will be the number of rows. So that's what I've done. And then I'm doing it for test and train. So I want to see if they are missing values, are they different between the 2 data sets that we have? So this is what I'm doing. So the train set is this red or pink? Test set is orange. Eh? Test set is blue. So you can see on this good, bad. Eh? For missing value for the train set is 0, because we all have the values, but for test set, it's 100% missing because we don't have. That's what we are trying to predict. It's a column existing. So if you go to the train performance, there's a column called good bad. And in the description of the challenge, they've said that column called good bad is a measure of whether a customer will default or not. So in our test data set, we are supposed to create our good bad. Then they'll evaluate. They already have the answers. So they'll see from the answers you're getting, they match with what they have. So it's an existing column. What I've done is I've now changed it from good bad to 1 and 0. Yeah. So after that, I'm trying, okay, this is another, thanks to the guys in Kaggle, I just found a fancy way of representing my missing values. So now I want to look at demographics and previous data, percentage of missing, where if it goes towards purple, it's highly missing, and if it's blue, it's, so it's just a fancy way of presenting. You know, guys like visuals. So when I'm going to do my presentation, say to my boss, and guys, I just want to have visuals for ease of communication. So I can see the bank branch clients, 99% missing, education 86%, and then here referred by is 94% missing. So should we drop the missing or have them? That's a question that I wanted to ask. What are your thoughts? Drop them, raise your hand. Don't drop them. So that's only one person. Don't drop them. Then the rest know what's happening. Depends. Yeah? It depends. Yes. So you have drop them, don't drop them. And then it depends. On what situation? Anyone who doesn't know, you're just there. Okay. So let's see. So now I know my missing values. I know how my variables are distributed. So I just want to do an analysis of my variables and see if I can be able to create new features out of them. And so in most, like say credit models, you'll just be using like 3 parameters for analysis. You'll either be looking at the weight of evidence, and you guys can go and check it out. So weight of evidence is basically a matrix to distinguish how a variable can clearly distinguish a good and a bad. So, and the way it's calculated is the natural log of the percentage distribution of goods over percentage distribution of bad. And then the information value is a summation of your weight of evidence based on those buckets. So when most guys who are doing credit modeling, you will use your weight of evidence or information value so that you are able to only remain with variables that can clearly distinguish a good and a bad customer. And also you guys look at things like Pearson coefficient and maybe Pearson correlation, and then there's chi-square statistics. So that's what is commonly used, but for our case we'll try and do it differently for purposes of learning. So I now have my 3 data sets. So what I do is so I said in Python, when you are merging with duplicates, it will end up giving you more rows than you have. So what I'm doing, I'm dropping duplicates, and then in place just means that in the variable that I'm working on to make the changes in that data set. So, and then I keep last. I can decide either to keep the first one or the last one. So after that, as I said, now I'm going to work on the data, because now this is demographics data. So how I'm working from the left to the right. So I don't need to work on the customer ID, because this is just an identifier. So it's just for tagging. So I'll start with birth date. So I know I can't work with that. So what I do, I try to create age out of that. And since the challenge was for 2018, so I just put 2018 minus birth date here. It gives you your birth date, yeah? So I now have a column called age, which is your natural age. Then I'll drop the birth date. It's no longer useful to me. And then most machine learnings are poor with numerical data. If you have age that is distributed between 0 and say 30, you can have 30 different values. So it's advisable that you change your numerical values into sort of categorical values. So that, and that's what I've done here. So for age, guys, I'm just looking if you are between 0 and 13, you are child age, 13 to 31, you are young age, and then 31 to 51, middle age, then 51 to 100, you are senior. So that's what I'm doing. I just want to convert now my continuous variable into sort of categorical variable, which then will enable the machine to clearly distinguish behavior. Because if you have age for, say, 50 students, and each one has a unique age, then you have 50 parameters to try and work with. So that's what I'm doing with this column. So I'm creating I'm actually mapping the age data that I've calculated into categorical. Then I looked at bank account type. So I see there is savings, then there is others, then there is current. So because I'm seeing current, it's very few observations. So what I've done, if you are in current, I move you to the others category. Yeah? So you can do it differently. It's just a matter of preference. And then, so basically I wanted to do guys who are your employment status versus your saving status. So for numerical variables, there are ways in which we try and do analysis for them. So you'll probably look at your measures of central tendencies. So you look at your mean, max, mode, median, and the minimum value. And then you'll measure dispersion. So you look at your standard deviation. And then after that, if you want to plot, then you'll do your histograms, and then you'll do your box plots. But for categorical variables, we usually do frequency tables and pivot tables. So this is what I'm doing. So I want to look your employment status and then versus your account type. So you can see guys who are permanent, majority of them have savings account, which is what I would have expected. And then, interestingly, we have students also have savings account. So self-employed guys now, if you look throughout the data, they are the only ones who have an inverse relationship. For these other guys, you see majority have savings, but for self-employed guys, you see a lot of them have other account types, and then a few guys have savings account. So these are the things that as I'm working through the data, you note them down, so that you then go to talk to the guys who are account opening guys, and you ask them if actually this is true. So as you're doing analysis, you just note the points that you're making down, and then you'll use them later. Then I did the same for level of education, and then bank name clients. So these are the banks in Nigeria. So it's highly, it has high cardinality. I have about how many values are they? About 20. So I'll drop this variable. Then bank branch clients, again, I think this is the location of the branch where it's located. So again, high cardinality. So employment status, as we have looked at it, I just try to have a feel of the values, and then so bank name clients are the same. So what I did, and thanks to, there's a guy called, forgot his name, there's thanks to a French guy who, just looking at how he's looked at the data. So the guy said that if you have your bank names, so you have your GT Bank, First Bank, Access Bank, then is there any other data, just suppose as me dropping those values, is there a way that I can get value from that data? And then, and this is where, guys, we are saying you need to apply your critical thinking. So just like locally, if you bank with, say, CBA, and I'm not marketing CBA. If you bank with CBA, and then there's another guy who banks with, what's the name? And no offense, say Oriental Bank. When you are trying to assess the credit value, who's, just from intuition, who's more risky? The guy for Oriental or the guy for CBA? So, and that's what this guy was saying. So what this guy was saying is, if he can be able to get the liquidity ratio for all the banks, then it can be a useful metric for him to then apply. And basically what he was doing, he was segmenting the bank types based on their liquidity ratio and profitability. So if you work, so there's a guy who banks with equity and they're highly profitable, so it gives you some advantage. So guys who bank with, say, these tier 3 banks, then sort of penalizes you. And so this is what he had. So you had he has the bank name, and then return on equity, loan to deposit rate, all these things. And then now he was merging this data with the original data that we had. So this is what he did. So he merged the data, and so basically what he's doing, you see, he's saying left on. So the left data set is the demographics data, and the column is so you see, when you are doing joins, the columns have to be the same. So instead of renaming and saying that I need to have bank name clients on all data sets, so he was saying when you are doing your merge on the left data set, the name is called bank name clients. But on the right data sets, it's called bank. So that's basically what he was doing there. So we got the data, and so on that list, these 4 banks were not there. And then we looked at deposit data for those banks in terms of revenue, the age, the asset base. So, so again, he did the merge like that. So the 4 banks still remain. So now, at least now when he will be dropping, even if he drops then the bank name clients, he has the details about that bank. So he has the bank asset ratio, assets, profitability, and stuff like that. So after working on this data set, I had how many rows? I think I had a couple of columns all the way to this side. So what I then decided to do is let me drop the columns which I feel are now no longer useful. So the first one was bank name clients. This one, because I've already merged based on the liquidity ratio of the bank, and then bank branch clients is the branch of the customer. So I wasn't able to make much sense of the longitude and the latitude columns that were given. So if you guys, any one of you makes use of that, then you can share with us. And I guess that's basically would have inferred maybe the location of the branch. And then birth date, because I already have the age, I no longer need it. And then these 2 columns. So I've dropped them. I now go to my previous loans. And I think this is now, so I've not even done, so basically what I've removed is just based on intuition. So say I've already created age. I don't need your birth here because I already have your age. So but when we go down, now we'll drop the variables based on our statistical significance down. So this one is just at a high level. If I already have your liquidity ratio and the assets of the bank, then I don't need the bank name. So that's what I was doing. So then I went to the previous data. And if you look at the previous data, a customer can have more than 1 previous loans. So you have multiple customers there. So the first thing that I did, and there's a friend of mine who, when I was going through this challenge, he was trying to explain to me some banking concepts. He's a traditional banker. So I looked at, say, profit, and you can call it whatever you want to call it. It can be interest, it can be profit. So the way banks work is they charge you a fee on any credit facility that you take. So you are given the due amount that you're supposed to pay and the principal amount that you borrowed. So basically what I was calculating is what's the difference between the principal and the due amount, basically the interest, or you can call it profit, interest, whatever you decide to call it. So that's what I was doing. That's the first column I created on the previous loans. Then, so this is your repayment profile. So if you are the loan, I've approved the loan today, and then the loan is running, like, say for instance for Mshwari, it's a 30-day loan. I want to check at what point did you pay your loan. Did you pay within 2 days, 3 days, 4 days, or even more than 30? Because I already have the term. So the term of the loan is fixed. So this is what I was doing. So you pick the date the loan was closed and the date the loan was approved. Then I get the number of days that you took to pay your loan, and that one I'm calling it return days. And then I'm just mapping it into an integer. And then, so after I've gotten that, remember I have the term of the loan. So the term of the loan is, say, 30 days. And you've paid, it took you 16 days to pay. So then I get the difference. So, and then I say the days the days left for your repayment is now the term of the loan minus the return days. So if you paid outside the term, I guess it will be negative, yeah?
So one of the guys was saying,
yeah,
one of the data sets is not under Zindi.
Yes. Yeah, and that's why I mentioned this guy, yeah, because he's the one who gave the data. When I upload in GitHub, it will have all the data sets, yeah. So don't worry about that. So that guy, I think, is Tunisian or something. So he went and looked for, I don't know where he got it, but he found data about liquidity ratio of the banks in Nigeria at that time. So that data is, so the guy just thought outside the box.
So he did extra homework.
Yeah, so he did extra work. So that's the thinking aspect that, and just try to see if I get that data, will it be meaningful when I go to model. So what I did is, so as I said, the data in the previous loans, a customer can have more than one. So what I did is I grouped by. So I created pivot tables based on the customer ID, And then from the pivot tables, I then summed up the necessary columns that I wanted. And so this is the guy is called Sadiq, who was just trying to give me like how he was doing it. Ideally, what I would have done, I would have grouped by, and then just the same. You do a group by statement, and then you sum up your columns. So for him, the easier method was to use pivot tables. So which is ideally the same. So and then so I was calculating total profit. So I get the value of profit, and then I do a sum of it. So if you have 3 loans, and in the 3 loans the interest we are charging you is 2,000, 1,000, and 1,000, then the total profit for that customer is 4,000. So that's what I was doing. And then average profit, the average loan amount you take, because remember you have multiple records. So I want to know if you've taken like say 10 loans, what's the average amount that you usually take with us? And then term days, the loans that you are taking on average, are you taking 6-month loans, 1-month loan? So that's what I was doing. And then I looked at early repayment, and then the average days left to repay. So basically what I did with the previous loans is after grouping the customers, so I was trying to get averages and summations of those columns, so that at least I can then map that value to an individual customer ID. And then after that, I just picked the variables that I've created here. So total profit, average profit, loan amount, and then I put them in and then I dropped the customer ID. I put them in a variable called data, and this is how it looks. So now, in these previous loans, I now have customer ID, and then your total profit, average loan amount, term days, days left, and early repayment. And as you guys will notice, when we will go to modeling, you realize that these extracted features actually have a very high performance in the model. So I have that. Then I went to performance. So performance.
Sorry, Billy.
Yes.
Before you move, sorry.
Yeah. No worries.
I don't want to just proceed.
It's
So,
Inner voice.
so the total profit, the column you just derived, total profit,
Yes.
profit,
loan amount.
guides you to, because I believe those are not in the data set.
Yes.
What is it that is guiding you to deduce those?
Yeah. So and this is now where, if you are working in a bank, your banking knowledge has to come in. And this is at the point where now you leave your desk, you go and sit with the bankers, and then for them to explain to you the concept of banking. So total profit or total interest is, if you take a credit facility, I'll charge you for that. So I'll give you the principal amount that you've requested for. If it's 20K, then I charge you an interest amount on that. That interest is profit to the bank. So say if you've borrowed 2,000 and then you're supposed to repay 2,500, the 500 is profit to the bank. Now, if you've borrowed 10 times, so you've paid, you've given us 50,000. And then there's a guy who's borrowed 1,000 and the interest we've charged is like 100. He's borrowed 5 times. So his profit is 500. So the guy who's giving you 50,000 and 500, is there a difference? Yeah.
But you're trying to determine who we can give a loan to.
Yes, yes.
Will your model prefer the guy who's giving you more money or the person who's paying faster?
So that's what we'll check. When we run the model will tell us if high value of profit is a clear distinguisher between default and repayment, because that's what we want to get. Every variable that you get, it then has to explain whether it's a clear distinguisher between a repair and a defaulter. So as of now, I don't know whether the guy who's giving me more profit is risky or not. But from intuition, I would rather keep the guy who keeps on borrowing and paying, because I'll make more money, and just unless you don't pay. And that's why I added the column average term days. So you see, like this guy who has the number 3, he's given us 16,500 and then he's repaying within 20 days. This other guy, 19,500 within 37 days. Are the two different? Which one would you prefer? I would prefer the third guy, yeah? So that's what I was doing, just from the previous loans. So this is the stage where you sit now with the domain experts for you to clearly understand how you can then get value of the data that you have. So these are not there. These are variables that have been engineered in the data set. Then I look at performance. So performance is where now we have the labels. So we have your good, bad, and then we have all these other features. So in the performance data, I created also profit because it's for the current loan that you have. And then I dropped all these other columns in the performance data. Because actually, for performance, I just need your label and maybe the amount, because the amount can infer your label. And the way credit models work, and maybe I should have mentioned this earlier, you take a sample of customers at a point in time. Then from the sample of customers that you have, you then set out an observation window. So you say, I'm going to observe these customers, say, for 1 year, 2 years, or 3 years. After the observation window, you'll then have, you've specified your performance metrics. So maybe if the customer stayed for 10 days, is a bad guy or a good guy. And then what you go and do is you go and look for historical data before the point of application of the credit. So, and that's why in this data set, we have sort of 2 data sets. You have your previous behavior, which is your historical data. So before you applied for the loan, what were the features about you? Then after you've applied for the loan, we've observed you for a given window, and then we say, okay, you ended up defaulting or not. So from the features that we got at your point of application, are we able to infer your future behavior? So that's basically what we are trying to do. So, and here, the reason I'm remaining with profit is because someone who has defaulted on a loan of, say, 100 and a loan of 1 million, they are 2 different cases. And that's why, even in this data set, I've kept the column for profit. So I just want to observe, okay, you've defaulted, but what's the amount that you've defaulted on? And then I dropped these other features. So as I was saying, now I just want to look at the data. For numerical variables, I was looking at, so I plotted some graphs. So what I did is, I was trying to see, can I get patterns between guys who are paying and guys who are not repaying in terms of distribution. So this is for loan amount and then for defaulters. So, and I think the pattern is almost the same, but you can see these guys, it's frequency of these customers. So how many are they? Yeah. So, and then this is the amount. So I was just trying to see, can I get a pattern out of someone who's paying or someone who's not paying? Is there something that I can clearly see? But from this one, it's almost the same. I have a good guy at 60,000. I have a bad guy at 60,000. So that's just what I was trying to do.
Sorry, from the data,
Yes.
defaulters are many. Because the defaulter scale is a bit high.
Yeah.
Does it mean defaulters are many?
No, it doesn't mean that.
Then where are the skills that different?
So what I did is learn amount. I want to see where is my flag. 0, green. Okay, so it's the vice versa. Eh? I've interchanged it. Eh? Yeah. This is the problem of always knowing that.
You can just change the title.
Yeah.
I'll change the code. Eh? So this is 1. And this is 0. Just to make sure that my code runs. So, and then the title, of course. Eh? So the title now is okay. Okay. Then I looked at loan number. So what I was doing is I was just looking at these numerical features that I've remained with and tried to see if I can get patterns. So highest loan number, the guy had 34. The lowest loan number is 2, the average, and then the median. Just trying to have a feel. Now, after going through all that process, I then now I started merging my data. So remember, data is the one that I had the previous loans where I had averages and sums. Then I mapped it on the performance, and then I'm doing an outer join on the customer ID. So I have that. So now I have my data. This is now data based on previous loans and performance. So I have now one data set. And then, so I then try to get new features, the deviation for the loan amount, profit deviation, and time-based deviation. So I was just trying to get new features out of it. And then after that, I then now merged my performance previous to the demographics data set. And here I did a tail so that I just see what's happening at the end. And then so what I did is, so remember I had put my data set I had created a column called set where I had test and train. So I then dropped it because I actually realized that you can actually use the missing value in the performance label to differentiate the data. I dropped, as I said, if you guys find a way of working with latitude and longitude, let me know, because I didn't know how I'll use it. I just decided to drop it because I couldn't explain how am I going to use it. Yeah. But if you guys can look at it, just share with me any ideas that you'll find from that. Now, I have engineered my features. Remember, when you are doing your model, you want to have few variables that gives you the best performance. So ideally, you'll want like between 8 to 15 variables that can actually give you good performance, so that even if you continue adding other features, there's no gain you are making in your model. And that's where the concept of feature selections comes in. So feature selection, we have three ways in which you can feature engineer your variables. There's what we call filter methods, there's what we call wrapper methods, and then there's what we call embedded methods. And you guys, when you have time, just go and try and look more on that. For filter methods, sorry, we have you are doing with things like correlation, so chi-square statistics. So that's what you do for filter methods. So those are filter methods. You are looking at things like correlation and things like chi-square statistics. So they're pretty much univariate statistics. So it's a variable by a variable. That's what you are doing. And then we have wrapper methods. So wrapper methods, and these you can go and read more about them. So it's basically things like recursive feature elimination, and then we have embedded methods where you look at things like regression models. So you run like your stepwise regression and gradient boosting models to try and reduce your features. So when you have time, guys, just go and read on the three variable selection techniques. Here what I did is I started with correlation. So what I did is I exported my data. So what I was doing now is just importing that CSV. So remember, if I've taken all this time to prepare my data, I need to save it somewhere so that when I now want to do something else, I don't have to run through the whole process. I just pick now the data that has already been prepared. So I did a correlation. There's that the core.core function, which gets me the correlation. And then what I did is I exported that correlation matrix. So here what I did is I imported the correlation matrix, and basically the way you interpret it is the same variables should have a correlation of 1. So this is what I got. Then I created so the good bad variable. So what I wanted to see is how is the variable correlated with the response variable that we are trying to predict. And so I looked at that, and then I dropped missing values. Then I looked at the lower level. So and then so what I did, you remember, for my test data, the good bad is not there, is missing. So what I did, because I need to get the entire matrix, I then transformed. If my test data is missing, I give it -1, that at least I can calculate that correlation, and that's what I was doing here. And then I got that. So what I did is there's this function, and I can't remember the name of the guy. I can't remember the name of the guy, but I got it from Kaggle. So basically what you are trying to do is he's trying to see the distribution of the features if they are different. So so it's a whole function. Just go through it. You'll see if separating the variables good and bad, and then doing a distribution. So for this specific variable, loan amount deviation, how is it different between the train and the test? So this is basically, and you can see the difference is not that big, sort of the same distribution. So then I said if a variable has greater than 0.9 correlation coefficient, I'm going to drop it. So, and this is what I was doing. So I just set a threshold there. You can decide 0.8, 0.7, because I had very few features. I didn't want to lower my cutoff. If I had features, like 100 features, I'll probably lower my cutoff to about 0.8, but I think 0.9 is good enough. And then, so what I did, I wanted to get correlated pairs. This is now just for my own analysis. I look at average loan amount, and I see it's correlated with total profit. So when I look at the average loan amount, I want to get the correlation in descending order with the top like 5 variables. So average loan amount, of course, it's correlated with itself with a correlation of 1, and then total profit, loan amount, early repayment, a loan number, like that. So then what I did is I plotted to see is it actually true what I'm getting. And this is a point of a perfect correlation where if the loan amount increases, then the average loan amount increases. So you have like a straight line. Yes. Yes.
Between the different other on the target?
with each other. Yeah, but then I had another segment where I was checking with the target. Yeah.
And do you remove any or?
So I'm going to remove. Yeah. I'm going to remove. So this, what I'm just doing is I'm just trying to see if these correlations make sense. Yeah? So we are okay? So like for this case, I'd already seen average loan amount is correlated with total profit. So I'm just plotting to validate that it's actually true. And you can actually see if one variable increases, the other increases. Yeah? So remember I had created this function to drop collinear features, and I'd put my threshold at 0.9. So what I did is I came down here, and then I tried to look at correlation, and I was looking at, I'm picking like the top end. So what I did is I passed my data through that data set, and then I looked at how many columns in the entire data set have a correlation greater than 0.9. And then there are 5 columns. And those variables are there. So at this stage, if I feel like I don't need to drop loan number, I can just ignore. But for purposes of this, I had to drop. So I dropped them. Okay? So that is, we've used filter method to reduce our features. So the next method that I wanted to use for feature reduction is the embedded method. And I was using light gradient boosting model, light GBM. So what I did is, so this is my data set, the merged data set. So because I want to refer to the original data set downstream, I just created a copy of that. And I dummified the variables. So these categorical variables, I turn them into numerical variables so that I can pass them in my model. But I later show you models like CatBoost, where you can actually pass your variables as categorical variables. Yes, so I said like most of these models are not good at working with categorical data. Like you have string values. Machines are good at working with numeric, 0, 1, 1, 2, like that. So if you have a string variable, like my bank type is savings and the other one is, say, current, the machine is not good at that. So what I'm doing, I'm transforming the categorical features into numeric using that pandas get dummify method. So if you look at the data set, maybe this would have answered your question. You see, employment status, permanent, retired. So this customer, if it's 1, it means is permanent. If it were opposite and say you have a 1 year, it means he's retired. So that's, I've just mapped the features into zeros and ones. Have I answered your question? Yes. So age, it's here. This is what you are referring to, yeah? So you remember we had senior, we had young age. This other age is not natural age, so I didn't rename the columns. This other age Y is the age of the bank. But this one is the natural age, which so I've dummified zeros and ones. So my train set, so remember, the way I was working with the data set, I've merged train and test. So now I'm going back to default settings. So I know my test data, I replace good bad with -1. So anything that has good bad that is less than 0 is test. But anything that has 0 and 1 is train. That's what I did. So now I now have my variables the way they should be, my data set. And I can see train is 4368, 1450. And then I have uniform columns across all the data sets. And then, because I'm used to, when I'm modeling, I'm used to having my, my response variable named target. So I changed good, bad to target, because there are functions that I have that I only work when the variable is called target. Yes.
Yes, there's one thing I don't understand.
Yes.
If the good bad flag is the target variable.
Yes.
How is it in the test set?
It's not.
Why are you using it as a test?
No, it's not in the test set. So remember what I had said. I needed to get correlation in the test data set. So I then put my missing good bad in test as -1. You understand? So that I can be able to get correlations and be able to see the distribution of variables. After I've done that, I have dropped it because it's not there. So the -1 now is going away. So in the test set, there's no variable called good bad, which I've renamed to target.
Which is the target variable?
Yes. You've understood the gymnastics that I did there. Eh? It's just to make my work easy. I don't want to do analysis data by data, and they're all the same. So I dropped the target in the test set, and then I dropped custom ID because it's not useful in the model. But I just had a label named train ID so that I can be able to get those IDs after. And then with a light GBM, one thing I realized, you have to align your columns. You see it's 34, 33, and then align to 33, 33. And then so I'm importing. So this is a function to run light GBM with the estimators. So I imported it. And then this is the code. And you see the results. So it's my validation AUC is 0.68. I iterated 400 times. So I'll explain that when we go to model selection. But for this one, remember I was using this for feature selection. So I then have my features. I know average days left has a weight of 483. It's the most important. And then I'm looking with the ones that have 0 importance. There are those, and then I'll drop them. This is just a plot. So average days less, you can see, and it's a feature. It's something we extracted. So it's very good at distinguishing good and bad. So if I was to model, I will probably keep this, and that's the importance, number of features. So as I was saying, this graph you cannot see it well, but when you check in your notebook, this is the number of features. But when you look at the graph at the top, it reaches a point where the graph now starts to plateau. So it just tells you, I can get that performance measure either by 15 or 20, and then after that, there's nothing that is going to happen in terms of performance. So again, I removed the features with 0 importance, and then I did the same thing and see if I'll get a different performance measure. So for modeling, I ran, usually what I do is I just try to run different models and then see which one gives me good performance. And then based on the outputs of each model, I try to figure out, based on my business problem, which is the best model to use. So this is just importing. I imported logistic regression, decision tree, random forest, and gradient boosting. So what I did is dummify my categorical features. This is another function now that I used, but it's just the same as get dummies that I used earlier. And when you look at these columns here, you'll see they've been mapped into zeros and ones. So once I have that, again, as I was saying, my good bad, I filled the missing values with 0. That's why I think it's important that I put -1. Then I checked, because you see, like things like logistic regression, you can't run them with missing values. So I just tried to fill the missing values. I now have my set. So what I did, separate train and test, and then I dropped the target variable in the test because it's not there. Then my X train, I have it there. So now I have my variables ready for modeling. I hope you've understood the steps that I've done there. So it's usually advisable to do a dummy classifier just to, because you need to have a baseline for you to know if your model is good or bad. So in scikit-learn, there's a dummy classifier. So what it does is picks the most frequent. So it assumes, like for our case, the most frequent was good, the ones. So it then sort of, it's just like giving every value the value of 1 without using any method. So if it finds like the entire data set, it will give everyone a 1. And then you get a measure. So my dummy classifier, if I use most frequent, I was getting 0.78. I was actually shocked because when I looked at some of the models I ran, the performance was lower than my classifier, which was actually guessing. So this is just a function I got from Kaggle. I use it a lot, but at least right now with libraries like li5 and Lime, I can easily explain these features. So what I did, I started running my model. So here I'm modeling. I started with linear model, so I did my logistic regression. I was getting an accuracy of 0.78. I'll explain these things baadaye, so you just take note of that. Then I was doing an area under the curve. I did a plot. So I'll explain all this when now we want to interpret our model. So I've run my model. That is my regression model. I've done my random forest, accuracy 0.76, the AUC 0.61. I've done my decision tree classifier, 0.69 accuracy, AUC 0.55. And the reason why I have this is if you pick a model and you decide to randomly guess, you'll get an AUC of 0.5. So this is just the baseline. So I want to know how good is it at performing. So I did my trees, and then after the trees, I did there's one. I did my knife-based model, 0.75. And then I did my XGB boosts, 0.79. And then gradient boosting, 0.79. So the next question before, so which model should I pick? Which model should I pick? If you have a model that one has an accuracy of 0.8, 0.81, 0.79, which one do you pick? Any thoughts? Go with the highest. Which one do you pick? Don't shy away from sharing your answer. So you say the best in terms of, the highest in terms of accuracy.
In terms of even the other measures.
Which other measures?
I think I'll go with the one with the highest accuracy.
Okay. Good point. With you?
I consider the one with the highest accuracy.
Yeah.
But is also farthest from the line that shows.
So you have two models. You have logistic regression giving you an accuracy of 0.75 and AUC of 0.65. You have your XGB boost, an accuracy of 0.8 and AUC of 0.5. They are all different. How do you pick? You can't pick both measures,
Then I will take the score.
the accuracy. But your evaluation should always be based on the problem you have in hand. So when you look at, there's a library called Yellow Brick, which is very good at creating interpretation reports. So what I did, I just ran a report of the XGB boost classifier. So how many guys have had know the idea of a confusion matrix? Yeah, so it's highly confusing. So, so the confusion matrix, the way it is you have your predicted values against your actual values. So if so the first block will be if you are predicting 0 to be 0, those are your the true positives, yeah? And then so you have true positive, and then the other one is false negative, true negative, false positive. So and then the confusion matrix is basically the basis of all the measures that we are going to use for measuring our. So that's the confusion matrix. Thanks to Chris Albion, he tries to make machine learning descriptions in terms of images and sketches. So you can go and check him out. So you have your true positives, false positive, false negative, true negative. And so from this is where we derive all our measures. So we start with accuracy. And I given an example why, who said accuracy? Yes, given an example why accuracy can be a wrong measure. And accuracy is a good measure when the target variable is balanced. In our ideal scenario, we have an imbalanced class of 22 to 78%. But basically, it just gets the number of correct predictions you've made. So your true positives and your true negatives, those are the correct predictions you've made over the total prediction. And in this case, the guy was saying, if you have 100 people and only 5 have cancer, your accuracy will always be 95%. Does it mean the model is good? Yeah. So from accuracy, the other one is precision. So, and then there's that example where, so you are just looking at true, so the number of actual values you are getting for your model. And then we have recall, so that when you go and see these values in the you can actually put some sense into it. So you have recall to find so it's actually true positives over true positive plus 4. So actually the top bit of your confusion matrix, it's also called is this sensitivity or specificity? Statisticians in the house, eh? And then you have a F1 score which just looks at the harmonic mean. So, and then this is one of my best tools that I use for evaluating my classifier. I usually use AUC, and so basically I would want my values to be high up towards 1, and then on this side towards 0. So the graph, if it's like this, it's a perfect graph, but you'll never achieve that. This is guessing, so I'll want to push that curve towards the corner. So I know that my model is good at that. So if you go through the notebook, and what I did is when I was writing, I submitted based on so I did XGBoost was I think the best, so I used it. And then so this is just, remember I had a function to calculate all these. If you check the notebook, when you are running those models, it was doing that. But this library called Yellow Brick can be able, you don't need to write those functions, just import those methods, and that's what I was doing. And then I submitted. This one was not so good. I think I wasn't getting good results. Then there's a library that I want you guys, when you have time, as we wind up, go and look at it. There is a Russian company called Yandex. I understand it's popular than Google in Russia. And so they developed a library called CutBoost. I've used this library. I think I've not been participating in these competitions, so this year I said I'll start participating. And I used this library, I think in both my submissions, and the performance was actually very good for this library. So for CutBoost, it's basically what it does. It's a gradient boosting model. So just go and look at it, and with CutBoost you are able to specify. You don't need to dummify your values. You just specify the categorical columns in your data frame, and then when you are running your model somewhere here. So this is what I did. I'm calling the categorical features here, and then and the number of iterations. So for this one, I wanted it to run 80 times and give me the best score. And then the best iteration was 31. So when I run the model, I'll set it to 31. So this is just about CutBoost. Go and read about it if you have time. And then the beauty with CutBoost, it can also gives you the important features in your model. So you can actually see average days left is one of the best, and also the weights. So I submitted these in that challenge. I think it was about. I think it's number 20. So yeah, in that challenge. I don't know how many guys are there. Yeah, it's number 20. So I have not had time to rethink about the processes that maybe I can fine-tune the model. That's your challenge. Go and beat number 20, and then I'll be happy to receive your comments. But this is a very good library in anything you do about classification. It actually has even for regression. So just try and look at it.